In this module, you will learn about Archimedes' principle. According to a famous Roman writer, a new crown had been made for King Hiero II, and Archimedes had to determine whether it was of pure gold. The king wanted reassurance that no silver had been added to the crown by a dishonest goldsmith. To do this, Archimedes needed to find a method to determine the volume of an object with an irregular shape. While taking a bath, Archimedes noticed that the level of water in his bathtub rose as he got in. He realized that he could use this effect to determine the volume of the king's crown. The submerged crown would displace an amount of water equal to its own volume. Based on this, he eventually propounded the Archimedes principle. This principle states that when a body is immersed completely or partially in a fluid, it experiences an upward force that is equal to the weight of the fluid displaced by the body. He could find out whether or not it was made of pure gold. Remember, mass of an object is a product of density and volume. So, knowing the density of gold and the volume of the crown, Archimedes could perform the necessary calculations to solve the problem. The Archimedes principle finds many applications in our lives. One of these applications is determining the density of a given liquid using an instrument called a hydrometer. A hydrometer is generally made of glass. It consists of a cylindrical stem and a bulb. The bulb contains a mercury or lead shot to make it heavy. This ensures that the hydrometer floats upright in a liquid. To determine the density of a liquid, it is poured into a tall jar and a hydrometer is lowered gently into the jar to float freely on the liquid. The hydrometer reading gives the density of the liquid. For example, if we place the hydrometer in a jar of carbon tetrachloride, the hydrometer shows a reading of 1.6. Thus, the density of carbon tetrachloride is 1,600 kg per meter cube. Archimedes' principle is also used in designing ships and submarines.